Hello physics students. Today we'll be talking about speed versus velocity. In the last video that you watched, you learned about the difference between distance and displacement and how to calculate that. And this lesson dovetails very well into that because these quantities these terms use distance and displacement in both speed and velocity. So let's get into it. So speed, you all probably think of speed when you're going fast, right? Speeding, getting pulled over by police. If you're speeding, speed is just a measure of how fast something is moving. It's a rate of change. So speed asks how fast something is moving. So you probably have heard terms in an automobile, let's say kilometers per hour or miles per hour. Also meters per second, feet per second. What do these terms mean? So really it's a rate of change, meaning it's how far I'm moving every second or every hour of travel. For example, if I'm moving at 30 miles per hour, that means I'm moving 30 miles every hour I travel. So if I travel 2 hours, we have gone 60 miles because we traveled 30 miles every single hour we travel. Same thing with meters per second. If I was moving at 5 meters per second, I would be moving 5 meters every single second of travel. That is what speed refers to. It's a rate of change, meaning I'm changing my distance or my position by this much every unit of time that elapses. So that is what speed. Now, do we think that this is a vector or a scalar quantity? Well, pause the video for a second and take a guess. If you guessed scalar, you are correct. We have a number with a unit, miles per hour. That is a unit of speed. It is not a vector because what is this missing? It's missing a direction, right? We don't have a direction in there, so it's just a scalar quantity. All right, so let's talk a little bit about velocity. Velocity is very similar. Velocity is the rate at which an object changes position. A rate at which object changes position. And so, velocity, well, let's do a quick demonstration here. So, I'm going to start the timer for 5 seconds. Ready, set, go. 4, 5. I've now jumped back and forth. Have I moved a bunch? Absolutely, right? I just jumped back and forth for 5 seconds. Have I moved my position? Have my starting and ending position, have they changed? No. So my velocity during that time, I have not changed my position at all. So in this example, I'm moving on average 0 meters per second. Now that may not be quite intuitive, and we'll get to kind of the calculation definition of velocity in the next video. But just know right now that velocity is just the rate at which an object changes position. And think back to the last video, which of our two distance quantities. We had distance and displacement. Which one of those talked about just the initial and final positions of an object? Now, if you guessed displacement, you would be correct. So velocity is a vector. So velocity equals vector. And so it being a vector, if I'm describing a velocity, it needs both a number, a unit, and it also needs a direction. So 55 miles per hour west. That would be a good velocity. The direction of the vector, we'll talk a little bit in class about vectors, what they mean, the mathematical definition of them, but really the direction of the velocity points in the direction the object is moving. So if I'm moving to the west, let's say, my velocity is in the westward direction. If I'm moving to the east, my velocity is in the eastward direction. Hopefully this gives you a little bit of information about the difference between speed and velocity. In the next video, we will talk about how to calculate the average speed or the average velocity of an object. Thanks for watching.